Okay, so today what we're going to be doing is we're going to be talking about a really important formula in mathematics called the quadratic formula, and that is this thing here. Now, what this formula allows us to do is it allows us to find a solution, or the real solutions to any quadratic formula that we're solving, regardless of whether it can be factorised or not. Okay? Now, what I'm going to do is I'm going to show you where it comes from. Okay? We're going to actually derive this formula here, right, by completing the square. Now, I've shown you guys how to complete the square in class, and we're going to do a little rendition of this. Instead of having numbers, we're just going to be using the general form of a quadratic here, okay? So what we're going to do, right, whenever we're completing the square, the first thing that we want to do is we want to get the coefficient of the x squared to be equal to 1, okay? So that means that any number in front of the x squared, we want to divide everything in this equation by that number. Okay, in this particular case, that number is a. So we're going to divide everything here by a. So what we do to one thing, we must do it to all, okay, to ensure that we keep things balanced. Okay, so I'm just going to move this up so you can see where we're heading with this. You'll notice here, a divided by a is going to cancel and leave us with just x squared. B over a is going to remain the same. So we have x squared plus b over a x, and we're going to have plus c over a, just coming down from there. You'll also notice 0 divided by a is just still going to be 0. That doesn't actually change our answer. Okay? Now we have a nice quadratic equation that we can work with where the coefficient of x squared is 1, so we can begin to complete the square. In class I told you the first thing that we should do whenever we're completing the square is move the constant term, this one here, to the other side. To do that we minus c over a from both sides. Okay? Right? You'll notice our next step is then going to become x squared plus b over a x, which these two are going to disappear, aren't they? Because c over a minus c over a becomes 0, right? And on the right-hand side of this equation, we now have minus c over a. Okay? The next thing that I told you to do when we were completing the square was we need to add on a special number, okay, and in order to generate a perfect square. Now that number that we added on in here, right, was half of the coefficient of x. And half of the coefficient of this x term, well, all we need to do is we need to double the denominator. So this becomes b over 2a all squared. Now we need to keep this equation balanced. So what we need to do, if we've added on the left-hand side, we must also add it onto the right-hand side. Okay? So whether you want to believe me or not, we've actually just generated a perfect square on the left-hand side. I'm just going to move this up. Everything that I've just underlined is actually a perfect square. Okay? And this perfect square is equal to x plus b on 2a all squared. Okay? Right? Now I'm going to show you how that comes about in just a moment. Let's just tidy up the right-hand side for a moment. So minus c on a. If we have a fraction squared, we square the top and square the bottom, just applying our index laws. So we have b squared all over 4a squared on the right-hand side. So I'm going to show you right now where this perfect square comes from, okay, and that we can get this original thing back, okay, just by doing a bit of expanding. Okay, so what I'm going to do is I'm just going to show you what happens when we expand out this perfect square here. We can rewrite this as being x plus b on 2a multiplied by x plus b on 2a, right, just because that's squared, right? Now I think I've shown you before while we've been in class, we apply something I like to call the moon method because it looks a little bit like a crescent moon when we're multiplying, right? Our first thing becomes x times x, which is x squared, plus x times b on 2a, which is b on 2a x, okay, plus x times b on 2a, so that becomes another b on 2a x, plus b on 2a squared when we multiply these two things together. Okay, so nothing too tricky so far. You'll notice if we combine the like terms in the centre, this is equal to x squared plus, and I'm going to not join them up the way that you might think. I'm going to have 2 times b on 2a x, okay, plus b on 2a all squared, okay? So again, nothing too tricky. You'll notice because we have a 2 on the top of a fraction and a 2 on the bottom of the fraction, we can simply cancel this out. So now we have x squared plus b on a x plus b on 2a all squared, which is exactly what we're after if we come back here to our particular equation. You'll see that we've actually generated it just like that, okay, just by expanding it. So that's where we've come up with, and that's the whole idea of completing the square. So now what we're going to do is we're just going to start tidying up this completing the square here, okay? If we look over here on the right hand side, what I want to do, okay, just coming back to this actual derivation, I'm going to leave the left hand side alone, okay, and come down a line. We're not going to touch that for the moment, okay? But this right hand side, we need to get that on the same denominator, okay? Which means that I need to multiply the bottom by 4a and the top by 4a, so we don't change our fraction. Now all I'm going to do, okay, is we're going to put this over one fraction in one step. So our new fraction will be b squared minus 4a times c is 4ac all over 4a squared, okay? Now all I've done is I've just taken the c around the other side, okay? I haven't altered anything. I've kept things in order with the negatives, okay? And because they were going to be on the same denominator, I've just put them over one just to save me some writing out, okay? So let's start playing with this a little bit more. Now we're nearly towards the end. We're just going to go over the page, okay, and we'll start to add in a few extra steps. Okay, so starting from that last step that we've just done, the next thing that we need to do is we need to unlock this bracket, which has got a square in it. And the opposite of a square is to square root. So we must square root both sides. Now I'm not going to show that in my red texter, but I might just write a bit of a square root, okay, so you guys can see what I'm doing to both sides. Whenever we take the square roots, remember, right, that there's going to be two possible solutions, okay? So we're going to end up with plus or minus the square root of b squared minus 4ac, okay? Now what I've done, if I take the square root of this whole fraction here, I can also take the square root of the top and the square root of the bottom. So I'm going to split this up into having the square root of the bottom like this, okay? You'll notice I'm just going to come across here to save me having to write this out another time. The square root of 4a squared, okay, is actually equal to 2a. Okay, you can see that? Now, what we're going to do, let's just come down a line. We now have x plus b on 2a is equal to plus or minus b squared minus 4ac, and taking the square root of all of that, all over 2a. We're nearly there. We are so close to being there. All we need to do now is to remove this b on 2a that is next to the x. So what we're going to do is we're going to subtract b on 2a from both sides, okay? That will cancel on the left hand side, leaving us with just x is equal to, let me come up slightly, is equal to negative b on 2a plus or minus b squared minus 4ac all over 2a, right? Notice that we have two fractions, don't we, on the same denominator, which just means that we can add the numerators together. Okay, so what we end up with is x is equal to negative b plus or minus the square root of b squared minus 4ac, okay, all over 2a, right? Now this here is our quadratic formula that we were after. This is the really important formula that we were trying to derive so we can use it to solve any quadratic equation that we want that has real solutions. Okay, so this is what we're after, and we've just started off from here by using the general form of an equation and completing the square. All we've done is completed the square throughout this. Okay, that is all we've done, and we've generated this formula that we can use to find the solutions to any quadratic that we want without factorising. Okay, so I hope this helps. I find this really interesting, and I hope you have too. Okay, thank you very much.